Hello everyone, so today we're going over 3.1 quadratic functions. Okay, so first of all, the quadratic function, like I said last time, quadratic function is a function of the form f of x equal f of x equal ax squared plus bx plus c, and this a is not equal 0. A not equal 0. This is the quadratic function. Any function of the form f of x equal ax squared plus bx plus c, such that this a not equal 0. Or I can define it as a polynomial function of degree 2. Polynomial function of degree 2. Okay, and also I was talking about how we can graph any quadratic function. So we have to change it to the standard form. So here, graphing of quadratic function, or here I can say graph quadratic function by using the standard form. Quadratic function by using the standard form. Who can remind me what is the standard form of the quadratic function? What is the standard form of the quadratic function? Anyone can remind me? What is the meaning of standard form? So if my quadratic function f of x equal ax squared plus bx plus c, what is the standard form of this quadratic function?
The standard form is f of x equals a parentheses x minus h close parentheses plus k.
Exactly. This is the standard form. Thank you so much. So this is the quadratic function. So this quadratic function, I can rewrite it in different way. The different way is called the standard form. Here is the standard form. The standard form, like he said, is the function f of x equal a times x minus h squared plus k. I can write this one as this, f of x equal a times x minus h squared plus k. I'm going to teach you how we can write this form as this form. So here we can write it. We can write it as f of x equal a times x minus h squared plus k. Okay. So also I said, like any quadratic function, the graph is look like a parabola. So I mean, if this b and this c equals 0 and this a equal 1, I'm going to get f of x equal x squared. And f of x equal x squared, as we learn to graph this function, look like a parabola. It's look like a parabola. So any quadratic function has, like, the graph of any parabola, the graph of any quadratic function is a parabola. So here the graph of a quadratic function is parabola. Such that this parabola has a vertex with vertex. The vertex is going to be h, comma, k. H, comma, k. So this is the order pair of the vertex or the point of the vertex. This h is come from here, from the standard form, and this k is this k. So this is the h, the x coordinate of the vertex, and this k is the y coordinate of the vertex. Okay, so any quadratic function is a parabola. The graph for any quadratic function is a parabola. The vertex is going to be the order pair or the point h, comma, k. And we have to know also if this a, if a is greater than 0, so the parabola opens upward. And the function also has minimum value is f of x, f of h equal k. So also we can use this a if this a is a positive number. So the graph of the function is going to be a parabola, but this parabola is opening upward of the function, and also in the same time the function has a minimum value is f of h equal k. So the two important things from a, this a can help me to know how is the parabola open. So the parabola is open sometimes upward or sometimes downward. So if this a is positive, so the parabola open upward, and in the same time we should to know the function has a minimum value. The minimum value is f of h equal k. It's the y coordinate of the vertex. It's the y coordinate of the vertex. So here we have to know this a is positive, and in the same times we should to know the minimum value is the y coordinate of the vertex. And also we have to know it's open upward, the parabola. Three important things. But now, if this a is negative number, if a is negative number, so the parabola open downward, okay? And also at the same time, the function has a maximum value. And this value is f of h equal k. So again, if this a is negative number, in the same time, the parabola is open downward, and in the same time, the function has a maximum value. The maximum value is the y coordinate of the vertex, okay? The y coordinate of the vertex. So let me, any question for these two things? Are clear? Okay, again, we have this very important. This is negative. The parabola opens downward, and also in the same time it has a maximum value is f of h equal k. So I'm going to graph this parabola and show you when this a is positive and when a is positive and when a is negative. So this is my Cartesian plane, for example. This is the positive x-axis. This is the positive y-axis. And the same things here we have, this is positive x-axis, the positive of y-axis. And my function here is f of x equal a times x minus h square plus k, and here a is positive number. And the same things here, f of x equal a times x minus h square and plus k, and a here is negative number. This a is negative. So because a is positive in the first this one in the first Cartesian plane, so the parabola should be opened how? Open upward because the a is positive. So the graph should be like this. This is the parabola open upward. And the vertex here, what is the vertex? What is the vertex of this function? Can one help me? What is the vertex of this function?
H comma k.
Yes, exactly. Look, the vertex here for both graphs should be h comma k. So h here is the vertex first of all. So the x uh, coordinate is, this is my x coordinate. This point is h, and in the same times this is my y coordinate. This point is k. So again, this point is h, the x coordinate, and this point is k, and here is the vertex. This is the vertex. It is h comma k. And in the same time, because a is positive, the function has a minimum value is f of h equal k. So the function, this function has a minimum value, and the value is k. The minimum value is k, or f of h. This point here is my minimum value. Okay, for the second diagram, Cartesian plane, I mean, my a is negative. So when a is negative, this is mean the parabola open downward. Okay, so the graph should be like this, similar to the first one, but opens like this. This is my parabola. And again, same like before. Here is this point is my vertex. Okay, this is the vertex point, and the vertex the same like I said, h comma k. So h and comma k is my vertex point, so it should be here, and this is my k. So here is h. This is h. This is k. Okay, again, this is the vertex here. This point is h comma k. This is my maximum value. Why? Because a is negative. So in the same times, my maximum value is k. F of h equal k. It's k. Okay, any question? Any question for this? No questions? Okay, so I'm going to give you an example. And in this example, we're going to learn how we can change the quadratic function of this form to the standard form. And after we find the standard form, we can graph any quadratic function by using these rules. So example, consider the function f of x equal 5x squared minus 30x plus 49. And the first part of this question, express f in the standard form. Number 2, find the vertex Number 3, sketch the graph of the quadratic function. Of f. Number 4, find the domain and the range of f. Number 5, find the minimum value or minimum or maximum, depends on the function, or maximum value of the function f. Again, f of x equal 5x squared here. Here's 5x squared minus 30x plus 49. Okay, I'm going to do the first one, and I'm going to explain how I can convert this function to the standard form. So first of all, f of x equal 5x squared minus 30x plus 49. First of all, we have to take the first two terms, they have x. So we're going to take the first two terms, the terms that has x, the variable x. Then we have to factor the 5. We have to factor the 5 from the first two terms. So after we factor it, what we're going to get? Who will factor this one? Factor the 5
You would get
from the first
5x,
5x.
parentheses x minus.
I need to factor just the 5 without the x.
just a 5. Okay, so then yeah,
Yes.
it would be x squared.
Okay.
Minus
Minus
6
what?
and then x.
Exactly. Thank you. This is correct. So again, we're taking the first two terms and we factor the coefficient of x squared. I mean, I need the coefficient of x squared after factoring equal 1. You see the 1 here the one is hidden. So again, we have to factor the number in front of x squared. So I get 5, open parentheses, x squared minus 6x plus 49. Now, we should to add b over 2 squared. Inside the parentheses and outside the parentheses, we should to subtract this number, the 5. This number is 5. Subtract this number times the b minus the b over 2 square. Again, inside the parentheses, we should to add the value b over 2 square. Outside the parentheses, I mean like here, we should to subtract this 5 times b over 2 square. Okay, what is the b here inside the parentheses? So I should,
Negative
like,
6.
as I learned before, f of x, exactly, it's negative 6. So this is my b here. For the quadratic function here, this is my b, the negative 6. So actually I should to add negative 6 over 2 square, and I have to subtract 5 times negative 6 over 2 square. Okay, what is the negative 6 over 2 square? What is it?
9.
9.
It's easy. It's a 9, exactly. Minus 6 over 2 is 3. 3 square is 9. So actually I get f of x equal 5, open parentheses, x squared minus 6x plus 9 inside the parentheses, and outside the parentheses I get 49, this 49, minus 5 times 9, this is 9. 5 times 9 is, what is 5 times 9?
45.
45. So now I get, now I have to simplify this thing. So I get f of x equal 5, open parentheses, x squared minus 6x plus 9 plus 49 minus 45, I get plus 4. Now the next step, I need to change this thing to something to the standard form. This is my standard form, f of x equal a times x minus h squared plus k. This is my standard form. So what I should to do now, as you think, to make this thing here similar to this?
You can factor the x squared minus 6x plus 9.
What, factoring, or we should to factor this thing here? What is the factor for this?
X minus 3 squared.
X minus 3 squared. This is correct. Nice. So again, we have to factor this just inside the parentheses. We're going to get something similar to this, to the standard form. So let's factoring inside the parentheses. X minus 6x plus 9 is, like she said, f of x equal 5 times x minus 3 squared plus 4. So this is my standard form. This form is similar to this. So f of x equal a times x, open parentheses, x minus h squared plus k. Is it clear? Any question? No. Okay. For the second one, find the vertex. So by using the standard form, I need to find the vertex. I need to sketch the graph. I need to find the domain after sketching the graph and the range in the same time. Then we can find the minimum or maximum from the graph or without the graph. Okay, for the second one, who will do the second one? What is the vertex? As I said before, it's h, comma, k. What is the h? What is the value for h? And what is the value for k from the standard form? Exactly, this is my h and this is my k. We take the opposite sign. Negative h means like we're taking the opposite of negative h. So it's -3, we have to take the opposite sign is 3, is 3. And the same sign for this is 4. Okay, Bilal, we have to take the opposite sign of negative h. So it should be 3 and the same sign for k, it's 4. So this is my 4, this is my k, and this is my h. There is h, and this is k. Again, look to this. The vertex is h, comma k, the opposite sign of h, minus h, I mean, and the same like k. For now, for the third one, we need to sketch the graph of f. So this is the vertex. And so to sketch the graph, I need two things. First one, I need to know what is the sign, how is the sign for the A, is it positive or negative? Second thing, we need the vertex. So I'm going to do it in the next slide. So again, f of x, the standard form is 5 times x minus 3 square plus 4. Yes. And the vertex is 3, 4. Now, to graph the function, I need, here is the x-axis. This is my y-axis. So first of all, what is the value for A? How is the graph? Is it open upward or downward? What is the sign of A? I mean, what is the sign for A? Again, this is my standard form. F of x equal A times x minus h squared plus k. Upward. This is correct. How do you know it's upward? What is the sign of, what is A here? The standard form is 5, exactly. This is my A. This is the value for A. And the value for A is 5, so it's positive, greater than 0. It's greater than 0. And going back, so if A is positive, the parabola opens upward, and the function has a minimum value is f of x equal k, f of h equal k. And at the same time, the vertex for both of A is positive or A negative is h, comma k. So because A is positive, my A is 5, so the parabola should opens upward, and also in the same time the function has a minimum value. So again, so the parabola opens upward like this, cup like this. like this. Okay, and the vertex is 3, 4. So the 3, 4 should be like here. Here is 1, here is 2, here is 3, this is 3, and 4 should be like 1, 2, 3, and 4. Okay, so the graph so the vertex is going to be here. This is the vertex here. And the parabola open upward. So the graph should be like this. Okay. So this is the graph of the function. And here is the, again, this is the point. This is the vertex point. This 4, 3, 2, 1, 1, 2, 3, 4. Any question for the graph? So now we know how to graph a function by using the standard form. We need two things, the vertex and the value for a. I mean the sign for a. This is the vertex, this is the sign of a. Question number 4. Find the domain and the range of f. What is the domain for the function? What's the domain for this function? What's the value for x? We use it to graph this function. This is the mean of domain. What you said, Layla?
3
Only 3 we use to graph the function.
and 4.
And 4, what else? 5. We use 6, 7, 8, because all this value has a y value. For all x, we said it has a y value. What about -1? Yes, it has a y value. -2, it has a y value. It's up. -3 has a y value. 0
As long
also
as it
has-
doesn't give you 0, right?
What about the 0? Also, the 0 has a y value. So what is the domain? All the positive, they have a y value. All the negatives has a y value. They have a y value. Also, the 0 has a y value. So what is the domain? Or you
So
can
would it be-
say what value we use it to graph this function. Yes, go ahead.
Would it be negative infinity, comma infinity? Would that be the domain?
Yes, this is correct. Yes, will be the domain. Or we can say equal R, all real numbers. So this is R, real numbers. Like this. So all real numbers is the domain, because if we need to graph the red curve, so we're going to use all the points, the negative, the 0, all of them, they give a y value. So all of them, they give a y value. This is mean domain should be all real numbers, is the domain of the function. Because every x in the x-axis, they give a y value in the y-axis. All the x, like all the x's in the x-axis, they give a y value. So I can plug any value inside the function here, and they're going to give me a value for y. This means the function has a domain, all real numbers. Now, what is the range? What's the range for this function?
Infinite?
Infinity? I mean, like for the range, what is the y value? What is all that y
4?
value we use it for,
I mean,
and what else?
Everything
Yeah.
greater than 4.
The 5 also, right? Exactly, everything greater than 4, and the 4 is included or not?
Yes, it's included.
Okay, perfect. So if we starting from the 4, as we see here in the graph, so the graph starting from the 4, they give me starting from the 4, and all value for x, if I plug any number in the x-axis, will give me greater than 4. The value should be greater than 4. So this is mean the range. Here is the domain. First of all, this is the domain. Here is the domain. Domain is from minus infinity to infinity, or I can say is the R, real numbers. But for the range is from the 4, and the 4 is included, to infinity. This is the range. Now, number 5. Find the minimum or maximum value of f. So it depending in for the value of a. This function has a minimum value or maximum value.
It has a
Is
minimum
this
value.
minimum value? This is correct. Why? Because the a is positive. So go back. If a is positive number, the parabola opens upward, and in the same times has a minimum value is f of h equal k. So a is positive, so it has, the function has a minimum value. What is the minimum value here? Is, what is it? What is it? It's k. What is the value for k?
4.
What is the value for k? 4, exactly. Again, here is the vertex. This vertex has an order pair 3, 4. And this 4, again, is my minimum value. It's my minimum value. So the minimum value is 4, the k. It's k. Any question for this? Okay, another question. What is, if I would like to add another question, will it always be the k? Yes, is always the k. Aisha, yes, always the minimum value is k. So my question is, what is, like, this is additional question. What is my x-axis, my x vertex, and what is my y vertex? I mean, x-intercept and y-intercept, not the vertex. What is my x-intercept and what is my y-intercept for this function? Three comma 0 is x-intercept, and Sandra said. 0.4 is y-intercept. No, this is my vertex. My vertex is 3 comma 4, but it's not the x-intercept. The x-intercept mean when the graph undefined, Aisha, Which one is undefined? Here Abdul Karim said there is no x-intercept. Again, what is, let me start one by one. What is my x-intercept for this graph? Abdul Karim said no x-intercept. Someone said undefined. Someone, there is none. Okay, what else? Who would like to answer what is the x-intercept? What is my x-intercept for this graph or for this function? Okay, what is my y-intercept? So for my x-intercept, like Abdul Karim, he said, and Aisha, both of them are correct. We don't have x-intercept for this graph. This graph does not crossing the x-axis. This is mean we don't have x-intercept. Where's my y-intercept? If this keep continuing, what value such that the graph, the red curve, intersects the y-axis? So what is my y-intercept? So the x-intercept, yes, we don't have x-intercept. It's none, undefined. Now, what is my y-intercept? Exactly, plug the 0 for x. What I'm going to get? 49, nice. Yeah, this is my y-intercept, correct. So to find the y-intercept, we have to set the 0 for x. And when we plug the 0, or we can plug the 0 for x. So when we plug the 0 inside the x, we're going to get 49. So the y-intercept is 49. And for the x-intercept, we have to set 0 for y. Then we have to solve it for x. Then we're not going to get any value. So we don't have x-intercept. So the y-intercept is 49, and the x-intercept is, we don't have any x-intercept. No x-intercept. Any question for this example? So another example. Find the standard form for the function f of x equal minus x squared plus x minus 2. Okay, the same like before. Find the standard form for the function f of x equal minus x squared plus x plus minus 2. So step by step, then after we find the standard form, I need to find also the vertex. Okay. First of all, we have to write the function f of x equal minus x squared plus x minus 2. Again, x times minus x plus 1 minus 2. Now we have to take the first two terms, then we have to factor it for minus x. What is the factor for minus x here? We should to factor for the minus 1. not for minus x, for -1 only, for the minus, this minus. What is the factor here? The both of the term for -1 only.
So it's going to be -1 parentheses x
Okay.
squared minus x
Minus
close
x.
parentheses -2.
Yes, nice. Thank you. So we factor the -1 from the first two terms. We're going to get -1, open parentheses, x squared minus x minus 2. Now the coefficient of x squared is 1. This is what I need. I'm focusing here. The coefficient is 1, positive. This is what I need. Now we have to complete the square. Inside the parentheses, what we should to do? We have to add here something and we have to subtract something from outside. What the thing we have to add?
-1/2 square.
Exactly, -1/2 square inside, and outside we have to subtract -1, this one, subtract -1 times this thing here. -1, it is -1/2 square. Again, inside the parentheses, I have to add the minus the b over 2 square. The b here is -1/2 everything square, and outside the parentheses we have to subtract this number times this. This number is -1 times this one is -1/2 square. Okay, let me simplify it. So I'm going to get now f of x equal -1 open parentheses x squared minus x -1/2 square. I will get what? Plus what? What is the value for -1/2 square?
Is it 1/4?
Yes, 1/4. And outside it's -2. Minus times minus is positive, and here I get 1/4 plus 1/4. Okay, so let me simplify it more. So I get f of x equal minus x squared minus x plus 1/4 minus -2 plus 1/4. This is actually the -2 is equal. This is over 1. So we have to multiply by 4 both sides. I will get -8/4. And -4, 8/4 plus 1/4, I will get -7/4. Okay. Now let's factoring this thing inside the parentheses. What is the factor? Let's factoring inside the parentheses. Equal what? F of x equal what? Oh, by the way, this is positive here. plus, plus, plus. So should be positive too. Positive, positive, doesn't matter. Okay, now it's good. What is the factor? I'm looking for two numbers. The multiplication is 1/4 and the summation is 1. What is this numbers? X plus 1/2 squared. This is correct. Nice. So here I can say this is equal minus x plus 1/2 squared. I'm looking for, again, 1/2 times 1/2 is equal 1/4. And 1/2 plus 1/2 is equal 1 plus 1 is 1 plus 1/2. And this is equal 2/2. And this is equal 1. And the same like here is 1. And here minus 7/4. So this is the standard form. This is the standard form of this function. Okay, from this function, what is the vertex? What is the vertex? The vertex is h comma k. What is h?
1/2 comma negative 7/4.
But we have to take the opposite sign of this.
It has
What is
to
the
be
opposite?
negative.
Exactly, negative. The opposite sign of this is negative 1/2, comma, here the same sign is negative 7/4. This is the vertex. You should to focus for the sign. So we have to take the negative, the opposite sign of this and the same sign for this, for the k. Okay, any question? Okay, so now we're going to learn how we can find the minimum and the maximum value without using the standard form. So before, we're using the standard form to find the minimum and the maximum value. Now we're going to find the minimum and the maximum value for the quadratic function without using the standard form. Okay, so here, finding the maximum value and the minimum for the quadratic function. Direct. Okay, so first of all, so I have my quadratic function is look like this. If this is my quadratic function, f of x equal a x squared plus bx plus c. This is my quadratic function. And by using this function, I'm going to find the maximum or minimum value direct without changing this or rewriting this in the standard form and taking because if I want to change it to standard form, I'm going to take a lot of times. So I'm not going to change it to the standard form. I'm going to find the minimum and the maximum direct from this quadratic function. So here I can say that the maximum and the minimum value for quadratic function happened at x equal, it always happened at this value, x equal minus b over 2a. Here, minus b over 2a. It's always at this point happened. So if this a, if my a is negative, I mean positive number, so this is mean the minimum value, the function has a minimum value. So the minimum is f of this point minus b over 2a. But if this a is negative, so the maximum value here without value the maximum value is of this point, f of this point minus b over 2a. So I'm going to give example to show you how we can find using this way to find the maximum and the minimum value direct. So my example, so I'm moving to the next slide. Here, example, find the maximum or minimum value for the function my function is f of x equal x squared plus 4x. This is my function, f of x equal x squared plus 4x. So first of all, to find the maximum or minimum value directly, we should to know what is the value for a. Then after we find the value for a, I mean the sign for a, I have to use this way. Okay, what is a here? What's my a value here? It's 1, exactly, it's 1. This is my a. Look back, here's my a. It's the coefficient of x squared. So the coefficient of x squared is 1. And this one is positive number, greater than 0. Because it's positive, this is mean the function has minimum or maximum. If a is positive, what does that mean? The function has a minimum value. And the value is f of b minus b over 2a. So actually the function has minimum value is f of minus b. What is first of all, because I don't want to get you confused, first of all, you have to write a, the value for a, the value for b, the value for c. This is my a. What is my b?
4.
4. What is the c?
0.
0. Exactly. So 1, 4, 0. So my minimum value is f of minus b. So minus b is minus 4 over 2 times a. So what is a? It's 1 again. So 2 times 1. And this is equal f of minus 4 over 2 is minus 2. Plug the minus 2 inside the function here. I will get 1 times minus 2 square plus 4 times what? Minus 2. What is the value? So f of minus 2 equal what? 4 plus what? One times, what is the value? What is the value here? F of minus 2 equal what? Minus 2 is, okay, minus 4 again. So minus 2 square is 4 plus minus 8. It's minus 4. Correct. Thanks, Michael. Here you go, Sandra. Okay, so this is what we need in this section. So by this we ending this section. I mean this section 3.1. So now let's go to 3.2, polynomial function and their graphs. So here polynomial functions. And their graphs. 3.2. So first of all, we have to know what is the meaning of polynomial function. So polynomial, I mean a polynomial function of degree n, for example. Who can remind me what is the meaning of polynomial? Polynomial of degree n. Anyone can remind me? from the second section of this book.
Polynomial function.
Yeah, what is the meaning
Would
of
it be
polynomial?
2?
Of order n, I mean, of degree n. If I said degree n. Did
Yeah.
you remember monomial or binomial or something like this?
Well, monomial means 1.
Monomial,
I'm guessing
I mean,
poly means more than 3.
yes. Yeah, more than 3. Can you, okay, but what is the meaning of monomial expression? Like as we said before, what is the formula for monomial function, like monomial function or monomial expression? Did you remember? Have you seen something like this before? A times x to the power k. This is in section 2. This is monomial. Anything of this form is called monomial. This is a monomial function. We said about this before. I told you the monomial function is a function of this form. A times x to the power k has only one term. This is section, I think, 2 or 3 in this book. And polynomial is a sum of this monomial. The sum of monomial is called polynomial. Like if I adding something like this, here is n minus 1 plus a n minus 1. I mean here n x to the power n minus 1, and we add many monomial. We're going to get something like this. So adding of monomials, something like that, we're going to get the polynomial. Polynomial is a sum of monomials, sum of this thing. Okay. We was talking about this in previous sections, but today I'm going to remind you what is the meaning of polynomial again. Polynomial function of degree n is any function of this form, b of x, here b of n of x. This n means the degree n, the highest power. This is equal a n x to the power n plus a n minus 1 x to the power n minus 1 plus until we get a1 x to the power 1, or it's x, plus a0. This is called polynomial. Now, because in this section I'm going to use different terms, the term is the leading coefficient and the leading term, because I'm going to use it a lot during this section. So that's why I mentioned the definition of polynomial. So this is called the leading constant, and this is called the leading coefficient. I mean, again, this is the leading term, this is the leading coefficient, only an. This is called the leading coefficient, and this is called the leading, like constant coefficient. Here, leading coefficient. And this a0 is called the constant coefficient. Now, this thing here, starting from an ending at x to the power n is called the leading term. This also I can call it as the constant term. So in this section, I'm going to use the leading coefficient a lot, leading terms, this definition, also the constant term and the constant coefficient. We should know an and an minus 1, and also all this a's, a1 and a0 is coefficients. All of them called coefficients. Okay, so before anything, let me remind you the graph of some functions. So before we graph the function, we'll graph basic functions. Basic polynomial function, basic polynomial. So if I have example, before we learn how to graph some basic polynomial function, for example, graph the function b of x equal minus x cubed. So we learn how to graph something like this. So first of all, we have to know how we graph the function x cubed, the original function. Then we have to flip it because we have minus here. But we should to flip it around the x-axis. Why? Because the minus is outside the function. Okay, so again, what is my original function? As I said, my original function is x cubed without a minus. This is my original function. How we can change this to make it similar to this? What we should to do? How we can change or modify the original function to make it similar to this, to graph the function? Any idea? Multiply by minus 1, this is correct. So if we multiply the both sides by minus 1, I will get minus O of x equal minus x cubed. And this is similar to the b of x equal, because minus x cubed is b of x, and this is equal b of x. So actually, to graph the function b of x is equal minus of O of x. This means we have to graph the original function x cubed, then we have to reflect it around the x-axis. Why? Because the minus is outside the original function. If the minus is inside the parentheses, this is mean we have to reflect it around what? The y-axis, as we learned before. We talked about this a lot before. So here is the graph of the function b of x, the polynomial function. So first of all, we have to graph the b of x, we have to graph the original function O of x. As we learned before, the graph of the original function is look like this. Like this. This is my original function. This is the x cube, x to the power 3. Now we have to reflect this curve around the x-axis. This is mean my mirror should be the x-axis. Here's my x-axis. This is my mirror. So all points should reflect around this curve, this line. So the 0, 0 should be the same point, and all these points should be here. And the same things for this curve from this side. Should be up like this. So this is the graph of the function minus x cubed equal p of x. This is the p of x. And for the black one is my function of o of x. This is equal the o of x. Okay, any question? So this is like a polynomial function, but today we're going to learn how to graph a hard polynomial function. This is basic, easy. Just to graph the original function, then we have to flip it around the x-axis. But we're going to learn like more harder polynomial function. This is basic because we'll learn how to graph something like this before by using the transformation. Okay. So before we going to graph any polynomial function, we have to learn something is called the end behavior. So this is the basic for how to graph any polynomial function. So graph of polynomial function by using the end behavior. So the end behavior is the basic to graph any polynomial function. This is very important. I'm going to teach you what is the mean of the end behavior. Okay. So first of all, the end behavior of any polynomial here, the end behavior of a polynomial function So suppose my function is b of x. B of x equal a polynomial function. So the end behavior determined by the degree n and the sign of an. So my polynomial function is look like f b of x equal again a to the power a times x. Here is n an xn plus an minus 1 xn minus 1 plus a1 x plus a0. So the end behavior always determined by the degree of n. If it's even or odd, this is mean the degree of n. If it's even number or odd, and the sign of an. Okay, so I mean, for this, we have like two important cases. Suppose my b of x, so here I'm going to say b of x, this is a polynomial function, has odd degree. What is the meaning of degree? Before to learn, to tell me what is the meaning of degree, what is the odd numbers? What is the odd numbers? What is the meaning of odd numbers?
You mean like numbers like 1, 3, 5,
Exactly.
7? Yeah.
Yes. 1, 3, 5, 7, 9. All of these are the odd numbers. Exactly, Amal. All of this, the odd numbers. What is the meaning of degree?
The degree is like the exponent, right?
What again? What you said?
The exponent of the number or the
Yes.
coefficient.
Any exponent, or the highest one.
The highest.
Exactly. So it's the highest exponent. Highest exponent. So the highest exponent called degree. If it's the highest exponent is odd number, 1, 3, 5, 7, 9. So I have two end behavior. So first one, now it's odd, the degree is odd, and an is positive. I mean, an is the coefficient of the highest degree. So the end behavior always should be the end behavior when x goes to infinity. This is mean y should goes to infinity. If x goes to minus infinity, so y should goes to minus infinity. And the graph of this function, if I need the graph, here is should be something like this. This is the graph. So when x goes to infinity, this is the value for x. When x goes to infinity, here is x goes to infinity. Here is when x goes to infinity, like this. Y should goes to infinity. This is mean y should goes up, like this. So the graph should be something like this. When x become larger and larger, the y goes up, larger and larger. When x is negative number, when x goes to minus infinity, like this, in this side, the y goes to minus infinity, down. Now, when an is negative number, the sign of an, the sign of the coefficient of the leading is a negative number. When an is less than 0. So the end behavior when x goes to infinity and when x goes to minus infinity. So when x goes to infinity, y should goes to minus infinity, always. When this x goes to minus infinity, the y should goes to positive infinity. So if I need to graph it to this function to learn more, This is my x-axis. This is my y-axis. I'd like to change this. Okay, so when x goes to infinity, the y goes to minus infinity. Supposed to be goes down. Like this, goes to minus infinity. And here, when x goes to minus infinity, the y goes to infinity, to the positive. Like this. So as we see here, the function, when become large, goes to infinity like this. Look to the y value, goes to the minus infinity. Yes, we flip it. Flip it around the x-axis. But if the same things here, when x goes to minus infinity, like this, the y value become large. You see? Same things in this one. When x goes to minus infinity like that, the y value become negative. Okay, any question? Is it clear what I said here? This is when when b of x has odd degree only. Now, when b of x has even degree, would be different. So odd degree has two cases: when an positive, when an negative. Now, when b of x has an even degree, same idea. So when b of x has even degree. What is the even numbers? What is the even numbers? Anyone can remind me what is the mean of evens? 2, 4, 6, exactly. 2, 4, 6, 8, etc. Degree is the highest exponent or highest power. Exactly, highest power. Now, when an is positive, the same like before, but different. So the end behavior when x goes to infinity, when x goes to minus infinity. So when x goes to infinity, the y goes to where? Again to infinity. When x goes to minus infinity, the y goes to infinity, positive. Go back for a second. Yes, go ahead. This is very important. You have to memorize all these things here. And the same things here is very important. So the end behavior, when x goes to infinity, the y goes to infinity. When x goes to minus infinity, the y goes to minus infinity.
Wait, Professor, can you go back, please? Sorry.
Yes, sure.
Okay, I'm done.
So if I have the graph like this is the graph. So like it's supposed to be something like this. I mean, for this point, it should be like anything inside, between. Doesn't matter what is inside. So again, when the function, when x goes to infinity like this, look to the graph. When x goes to infinity, the y value goes to infinity. When this happens? When the b of x has even degree, and also in the same times the an is positive. Same things in the other side. If x goes to minus infinity, all this value is negative. The y should goes to infinity. Okay. Now, when the an is negative, this is for positive an. Now, when an is negative, so an minus 0. Okay, so the end behavior for this, when x goes to infinity here, when x goes to minus infinity. So when x goes to infinity, the y goes to minus infinity. Yeah, when x goes to minus infinity, the y goes to minus infinity. Again, the graph of this function is not exactly the graph. It's like some function has even degree and negative leading. This is the leading coefficient. Like this. Again, when x goes to infinity like that, here is when x goes to infinity, the y value will be negative. The y goes to minus infinity. And when x goes to minus infinity, like this, the y goes to minus infinity, down. Okay, any question? Do you have any question? No questions. Okay, so next time I'm going to give you example, find the end behavior for this. So please just memorize the end behavior to get ready for the example. Okay, please read these things again, the blue one and the red one, to get ready for the example next time. Okay, I will see you next. I will see you Thursday. Wednesday. Have a good day.